This is Miss Green, and we are in the second to last section of the year. We're in statistics unit on data distribution for today and tomorrow. So this is 11.3a, day 1. Whenever we're collecting data for different reasons, we like to analyze it so we can make decisions about the data and maybe something that we're going to do in the future depending upon our results. So here's an example. Ken and Dakota were asked to estimate the mean and median of the following data set. So there was a score that was and the frequency of that score. And we don't know what it was. We don't really know if it was some kind of sports activity or something. The middle value, Chen said, was 11. Both the mean and median are approximately 11. And Dakota said most of the data are on the left. I think the mean and median will be about 9. So I think it's supposed to say, I think the median will be about 9 with the mean slightly larger. That's what that was meant to say. So is either Chen or Dakota correct? By the end of today's lesson, you'll be able to answer that question. What strategies could use to approximate the mean and median? And we'll have some tools to help you with that. And then which measure of center is more representative in this case, the mean or the median? That's something else that you'll be able to answer by the end of today. So let's look at finding the measures of center and spread. Do you remember mean is the average and standard deviation is how far these numbers are from the average? How much they vary from this average or this mean. You've done mean, you've done average for many years. Add them up and divide by the total number of items. Standard deviation is a much more complicated, well, if not at least more meticulous calculation. So we do like to use our calculator for these to help us. It alleviates many mistakes that we could make otherwise if we're doing it all by hand. I'm going to show you some steps on how to use technology to find the mean and standard deviation. Maybe you've done this before. That would be great. It doesn't hurt to review if you haven't done it in a while. So here's my data set, just in random order. The first thing I do is press the Stat button on my calculator. It's in the upper, well, the second row, the third button over. Then once you hit that, you'll choose option 1, which is Edit, and then you'll enter that. Then you'll get something like this, where you'll have L1 listed, and it'll just start, you just enter each number one at a time, and it'll give you a full list when you're done. You want to be careful that there aren't any other lists on there that you want to mess with that you're not using right now. There are ways to isolate them, but you can just delete a whole list. Other things you can do is you can write on top of a previous list, but when maybe you have one that has 10 and the new one only has 8, so the last 2 you actually have to delete using your delete button. Now once you put your list in there, choose the Stat button again, but this time right arrow over to the Calc option. So see the highlighted option here, Calc, and choose the one variable stat, because we're only going to analyze this one list. So we only want one variable. You should see a screen like this. See where it says one variable stats, and it says I'm using list 1. You can change that too if you want. And the frequency list, we're not going to mess with that right now, and then calculate. So you'll keep hitting enter, and when it gets down to calculate, you'll make a calculation. Then, now we can go to the next one. Then you'll get something like this. Now this is what you see first, but you can scroll down and see a few more calculations too. But this X with the line over, the little X with the line over it, that is your mean, that's your average. And then these are some other numbers that you don't need right now. For advanced statistics, you would use those. And we're going to use the standard deviation that has this little, I'm going to double check. I think it's a small sigma. It is a small sigma. So that's the standard deviation number that we will be using when we analyze our data. So the mean is 11.6 about, and the standard deviation is about 6.3. Now notice we're looking for this 5-number summary. What does that mean? These are the 5 numbers we're looking for. A minimum value, the first quartile, the median, the third quartile, and the maximum value. If you were doing this by hand, you would rearrange the data in the ascending numerical order. And you've probably done that before, but that sorting helps out a lot if you're going to do it by hand. Note that 3 is the minimum because it's the smallest here, and 25 is the maximum. Then to calculate the median, the one in the middle, we just divide the data set in half. So I have 1, 2, 3, 4, 5, 6, 7, 8 parts over here and 8 parts over here. Because it's an even number, the median is actually whatever is halfway between those. If it's an odd number, you just pick the one that's actually in the middle. Now this first quartile and third quartile, the first quartile, so this was the half, right? So we're going to cut it in half again. So now we have a quarter. And again, we have even numbers in each of these groups. So we'll do, well, there's nothing halfway between 6 and 6. It just is 6. So the first quartile would be 6. But these are different numbers over here, divided in groups of 4. So the third quartile would be 15.5. This one would be 6. With the median again was 12.5. And that's what this says, the same thing. Now, maybe we're not going to spend a lot of time making box and whisker plots, but maybe you've done that before. Notice here's my minimum, my first quartile, my median, my third quartile, and my maximum. Those are those 5 numbers that we can look at and analyze and find out more about our data. So I wrote them all. It's all right here again. On your calculator, if you scroll down a little bit, before, remember we had the X with the line over it, the mean at the top. If you scroll down just a little bit, you will see well, on this one, it's in order. I think on my calculator, it doesn't show up in order. It does the min and max together and the quartiles together. So just look closely to see how they're listed here. But notice here we have the 3 and the 6, and we have 12.5, 15.5, and 25 all in order. So the more advanced calculators do put them in order, but my 84 plus, not the CE, puts the min and max together and the quartile 1 and quartile 3 together. I want you to try this. List the mean, the standard deviation, and the 5-number summary of the following data set. If you're not sure how to do that, you're going to have to find the standard deviation using your calculator. So go ahead and stop the video, try that, and see if you get the same answers. If you don't, look carefully at your list because it's super easy to forget one of these numbers or type it in wrong, and that will make a difference on your mean and standard deviation and the other numbers too. Did you get this? And these are approximate. Some of these don't come out exactly, so those are approximate. These would be, the 5 numbers are pretty exact right there. Try this one. An electronics store has 8 computers in stock and the prices of the computers are shown below. What are the mean and standard deviation of this data set? So you can stop the video and try that. I found that the mean was $646 and about 88 cents, and the standard deviation is about $184. For our second example, we're going to look at appropriate statistics to compare the data sets. We've been looking at measures of the middle, right? And now we've looked at some spread values too. So now we're going to look at something else. We're going to compare the shapes. So we've looked at the center and the spread, and now we're going to look at the shape and see if that helps us make a decision. And actually the shape itself will tell us which of these measures of spread we should use. And we use them in pairs. When we're measuring center and spread, if we decide we're going to use the median, then we would use the interquartile range. If we decide we're going to use the mean, then we would use the standard deviation with that. Now the interquartile range, this is some measures of spread. We have already talked about standard deviation and range. I think you know that, but just in case you don't, it's the difference between the maximum and minimum values. Maximum, minimum. So put those in your vocabulary if you don't have them in already. Whoops. Then the interquartile range is the difference between the third and the first quartile. So that gives you some more data points that you can use. And again, remember, when we're measuring the center and spread, median and interquartile range go together, and mean and standard deviation go together. Let's look at this graph here. Looks pretty symmetric, doesn't it? This is a perfect world right here. So the mean, median, mode are all exactly the same number, and it's evenly distributed. Whatever this is the same as whatever that is. This spread here is the same. This is called a normal distribution. I'll put that on here. Normal distribution. Now that's the perfect world. Of course, we're not going to have a perfect world with all our data, so we want something that is close to that. But when we see normal, we want to think mean and standard deviation. Remember, those two go together. The mean, the average, and the standard deviation go together. Let's look at another type. This says skewed left on it, but most of the data is on the right. This one says skewed right, but most of the data is on the left. It seems opposite. I have a little trick. This is called my tail. And I know it's mean to pull a tail, but the tail pulls the mean away from the median and the mode. So the tail pulls the mean to the right. To the left here. This is my tail here. It's pulling. It's pulling the mean to the right. So that's where these left and right come from. Here the tail pulls the mean to the right, so it's right skewed. So the mean would tell us less about the data than the median, because the mean is offset a little bit. So the median would probably give us more useful information. These are skewed. You can read that if you like. Now, it says what measures of center and spread would I use to analyze the following data set. First, I want to know if the data set is normally distributed or somewhat symmetrical. And based on that, then I would decide which measures of center and spread I would use. Well, here I made a histogram, and look what happens. I would say that was not normally distributed. In fact, I could kind of draw a curve that goes kind of like this. So there I have my tail. It's pulling the mean. Remember, it's mean to pull a tail to the way the arrow's going, to the left. So this is skewed left, which means my mean could be about right here with my median maybe right here. I'm just guessing. But the mean would be less than the median. Since the mean is more affected by this data distribution than the median, when it's skewed, it's better to use the median. When you use the median, do you remember what goes with it? The interquartile range. And again, you can find that on your calculator. Use those. This is the measures of center, and this is the measure of spread. Also, the quartiles show how the data are distributed differently on either side of the center. So that's some more useful information. And sorry, I wrote over that. But you can see here that 21 is the first quartile, median is 29, and the third quartile is 33. The range then is the highest minus the lowest, max minus the min, and I get 27. And the interquartile range is 33, my third quartile, minus 21, my first quartile, so that's 12. Let's look at this data set. If you just looked at that data set, 55, 55, 57, 57, 57, 58, 58, 59, 59, 59, 61, 61. You can kind of imagine the histogram in your head. And you've got two 58s and three 59s and two 61s. And then you've got two over here. And these are only differ by 2, and then these only differ by 2. So you can kind of see how that would be spread out. So this is pretty evenly distributed. So the spread measures of spread and center would be using mean, which is 58, and the spread would be standard deviation, which is 1.95. If you look at this data set, just by looking at it, even before I've done anything with it, it seems really heavy on this side. And then not so, this is kind of spread out a little bit and not very many of those. So when you look at that, you're probably thinking, I should probably, since it doesn't look distributed evenly, those numbers, I would then use my median. This should say median. This is a mistake. Which is 135. And let me see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. 135 is halfway in the middle. And then the third quartile, since we divide those in 3, right? Would be halfway between there, would be 165. And then halfway here, the first quartile would be, whoops. And then lets you know we're almost done. 115, I would subtract 165 minus 115 and get 50. So now if you think about it, I should have put this in here. Sorry, I'm going to do it the old-fashioned way. Back it up. Okay. Now look at this. What kind of distribution do you think this is? Skewed right, isn't it? So it's pulling the mean away from the median. So the mean would be over here somewhere, and the median could be over here somewhere. When I use that, then what the values I care about are median and the interquartile range spread that you would want to use to analyze that data. this one was incorrect too. Now, if you look at the analysis here, actually on the left, yes, it is on the left. It's on this side. And the median maybe about 9, could be. I think that's possible. And the mean would be slightly larger. Definitely it would be over here somewhere. Maybe 11 or so. So that would answer these questions that we were talking about earlier. Now, if you wanted to get the exact mean and median, you would have to put this data into your calculator. And that might be a little tricky from a histogram, but you could do it. And so which measure of center is more representative? This one you would use the median because it's the median. Remember, the mean gets pulled away. So that kind of helped you go back and answer that. All right. I hope that helped you. And good luck and try 11.3a Math Excel.